Alright, I'm going to walk you through how to solve for the parallel circuits, the handout we did in class. Make sure you realize that a parallel circuit has at least one point where the circuit divides, creating more than one path for current. Each path is called a branch. The current through which a branch is called branch current. If current flows into a branch in a circuit, the same amount of current flows out again. This rule is known as Kirchhoff's law. Because each branch in a parallel circuit has its own path to the battery, the voltage across each branch is equal to the battery's voltage. So if you know the resistance and voltage of the branch, you can calculate the current with Ohm's law, where current is going to be voltage divided by resistance. So let's do these together. Let's do the first one together. So it says, well, what is the voltage across each bulb? So let's look here. I've got 12 volts, providing my total electric potential difference. I get 12 volts along this branch. I get 12 volts along this branch. The total voltage across each branch is going to be just that, 12 volts. So what is the current? Well, I can apply Ohm's law. It's going to be voltage divided by resistance. So 12 divided by 2 is going to be 6 amps across this branch and 6 amps across this branch. Well, what is the total current provided by the battery? Well, 6 plus 6 gives me 12 amps of total current. When solving for letter D, use the total current and the total voltage to calculate the total resistance. So resistance is going to be 12 volts divided by 12 amps to give me 1 ohm of total resistance. And at any point you can pause and go back. So I'm going to do 2 and 3 together here. Alright, here it goes. So use the parallel circuit pictured to the right for the next 4 questions. So what is the total voltage across each bulb? Well, it's going to be 12 volts here and 12 volts here. What is the current in each branch? Well, 12 volts, I can apply Ohm's law. 12 volts divided by 3 ohms is 4 amps here and 4 amps here. So the total current is going to be 4 amps plus 4 amps is going to be 8 amps. So use the total current and total voltage to calculate the total resistance. Well, resistance is going to be 12 volts divided by my total current of 8 amps is going to be 1.5 ohms of total resistance. So use the circuit to the right to answer the questions. So what's the voltage? Well, 12 volts in, I'm going to have 12 volts here, 12 volts across this. What's the current across each branch? Well, 12 volts divided by 2 ohms is going to be 6 amps. 12 volts divided by 3 ohms is 4 amps. So what's my total current? Well, 6 plus 4 equals 10 amps of current. So use the total current, total voltage to calculate total resistance. Well, resistance is going to be 12 volts divided by 10 amps is 1.2 ohms of total resistance. Remember, at any point you can pause and go back. So let's do number 4. So use the parallel circuit to the right. What's the voltage across each resistor? Well, this is going to get 9 volts. This branch is going to get 9 volts, and the last one's going to get 9 volts. So what's the current in each branch? Well, I can apply Ohm's law. 9 volts divided by 2 ohms is 4.5 amps. 9 volts divided by 3 ohms is 3 amps. And 9 volts divided by 1 ohm is 9 amps. What is the total current? Well, I can add these up. So 9 plus 3 plus 4.5 is 16.5 total amps of current. Now, page 2, it takes a little bit of a turn because I'm going to teach you 2 ways here. So pay attention to both. I'll let you choose which one works for you. So in part D, problems 1, 2, and 3, you calculated total resistance for the circuit. This required you to first find the current in each branch. Then you found the total current and used Ohm's law to calculate the total resistance. Another way to find total resistance of parallel resistors is to use the formula. That the resistance total is going to be the resistance in each branch multiplied together divided by the sum of the resistors together. Now this is one way to do it. I'm going to teach you another way too. So here's the example. Calculate the total resistance for a circuit containing 2 6-ohm resistors. So if I apply it to this, I can go 6 times 6 divided by 6 plus 6. So I get 36 divided by 12 is 3 ohms. The total resistance is 3 ohms. Now I'm going to pause for a second because I'm going to show you another way to solve for total resistance. And then I'll come back and solve these. The way I'm going to show you is called, to solve for the total resistance of parallel circuits, is called the reciprocal rule. Now some people choose this way over the other way. The current in a parallel circuit breaks up, with some flowing along each parallel branch and recombining when the branches meet again. The voltage across each resistor in parallel is the same. So the total resistance of a set of resistors in parallel is found by adding up the reciprocals, right? That's a 1 over a value of the resistance values, and then taking the reciprocal of the total. So the equivalent resistance values of resistors here, I've got 1 over R. The total is going to equal 1 over the resistance in branch 1, plus 1 over the resistance, total resistance in branch 2, plus 1 over the total resistance in branch 3. So I've got 3 examples here because I'm showing you branch 1, branch 2, branch 3. So the parallel circuit, the current splits up, and the amount going through each resistor depends on the resistance. So if the values of the 3 resistors are this. So in branch 1 is 8 ohms, branch 2 is 8 ohms, and branch 3 is 4 ohms. So based on reciprocal rule, right, this is different than what you did that we're going to be also working on. I'm showing you 2 ways. This one I'm using reciprocal rule. So 1 over 8 plus 1 over 8 plus 1 over 4 equals 4/8. Right? That's 1/2. But the reciprocal rule comes into play. So 1 over 2, if I reciprocate this number, it becomes a total resistance of 2 over 1. So my total resistance is 2 ohms. Right? 1 over 2, if I flip that, I get 2 over 1. So this is the reciprocal rule using this process. 1 over total resistance plus 1 over total resistance plus 1 over total resistance. It's this equation here. But I think this way is actually simpler. Now you can choose your own way. I'm okay with either one. But the individual currents can be found using current equals voltage divided by resistance. So the voltage across each resistor is 10 volts. So I have 10 volts here. So you would find that my current across branch 1 is going to be 10 volts divided by 8 ohms is 1.25 amps. Across branch 2 is 10 volts divided by 8 ohms is 1.25 amps. And my current over branch 3 is 10 volts here divided by, sorry, let me sort that out, divided by 4 ohms is 2.5 amps. So my total current is going to be 5 amps. So I get there the same way. I can just do the process using the reciprocal rule. Now the handout has you doing it this way, where you multiply the resistors times you multiply them by each other, divided by the sum of the two. Now you get there the same way. If for some reason the reciprocal rule does not work for you, you can use this way to find your total resistance of a parallel circuit. But only for 2 branches at a time, and that's the key. The reciprocal rule works for multiple resistors on a branch. This one you can only do 2 at a time. So if I do a practice problem with you using this rule, find the total resistance of a parallel circuit with 2 branches, each with 4 ohm resistor. Well, I can take 4 times 4, 16, divided by 4 plus 4 is 8. 16 divided by 8 is 2 ohms. Find the total resistance here. If I've got 2 10 ohm resistors on here, 10 times 10 is 100, divided by 10 plus 10 is 20, 100 divided by 20 is 5 ohms. Now for the sake of practice here, you can do it either way. So now I'm back on your handout. I solved all these using the reciprocal rule. So you can do it either way. But I want you to see this, but just so you have access to another way of solving it. Now you can always go back and check your work with this one. But here goes. So the total resistance of a circuit containing 2 8 ohm resistors. In theory, you could take 8 times 8 to get 64 divided by 8 plus 8 of 16, and you get 4 ohms. But let me show you a reciprocal rule. 1 over the resistance total plus 1 over R1 plus 1 over R2 is 1/8 plus 1/8 gives me 2/8, which is 1/4 in simplest terms. If I use the reciprocal rule, I take this final answer, fraction, and it's 4 over 1, and I get 4 ohms of total resistance. I'm going to do reciprocal rule for the rest of these. So 2 12 ohm resistors, I get 1 over 12 plus 1 over 12, which gives me 2 12ths. Simplest form is 1/6. Reciprocal rule means I flip this back, and I have 6 over 1, which is 6 ohms. Now you could find that 12 times 12 is 144, divided by 12 plus 12 is 24, and you get 6 ohms. So you get it the same way. I have a tendency of using reciprocal rule, especially when we start getting into multiple resistors on branches. So a 4 ohm resistor and an 8 ohm resistor, if I add this using reciprocal rule, 1/4 plus 1/8, notice I need to find a common denominator for 1/4, so it's going to be 2 8s plus 1/8 is 3 8s. I flip this for 8 thirds, and I get 2.7 ohms. And you could take 4 times 8, which is 32, divided by 4 plus 8, which is 12, and you'll get the same answer. Notice that that's actually 2.6 repeating. So we'll do letter D. 12 ohms times 3 ohms is 36, divided by 12 plus 3 is 15, and you get 2.4 also. But I'm going to show you the reciprocal rule. 1/12 plus 1/3, right? Find a common denominator is 12, so 1 over 12 plus 4 over 12 gives me 5/12. I flip this using the reciprocal rule, 12/5 gives me 2.4 ohms. So choose which way you want to do it. I'm going to say don't be scared of using the reciprocal rule, what I've shown you here, because a lot of times I'm going to be giving you more than just 2 resistors at once, and you're going to have to do them, and you'll have to do more steps if you use this equation here. So learn the reciprocal rule, know that you have it in your back pocket in case you want to use it. So the last one. So to find the total resistance of A, B, and C in parallel, first use the formula to find the total resistors A and B. Then use the formula again to recombine resistor C. And this is where I think the reciprocal rule comes into play. If you have 3 8-ohm resistors, I can just go 1/8 plus 1/8 plus 1/8 gives me 3/8. Reciprocal rule means I flip these. 8/3 is 2.7 ohms. I think that's a lot quicker. So you may choose to, for 2 resistors to use this rule here. And then for 3 or more, use the reciprocal rule. And that's kind of what I would recommend. So 2 6-ohm resistors and a 2-ohm resistor, I get 1/6 plus 1/6 plus 1/2. Find my common denominator. So this becomes 3/6. So 3/6 plus 1/6 plus 1/6, I get 5/6. Invert this to 6/5, it's 1.2 ohms. And lastly, letter C. Once again, I think reciprocal rule gets you to the answer quicker. So I have 1 ohm, so 1 over 1 plus 1 over 2 plus 1 over 3. I find my common denominator of 6, so I get 6/6 plus 3/6 plus 2/6. Final answer gives me 9/6. I invert this. I get 6/9, so my final answer is 0.6 repeating, or 0.7 ohms. There you have it.